30 mm and height 7 is resting on the ground with its base such that a base edge is perpendicular to VP. A base edge is perpendicular to VP. A base edge is perpendicular. Resting on ground HP. Straight. A base edge perpendicular to VP. Right. How about the axis? Axis is perpendicular to HP, so you have to draw the base on HP, right? That you know. So such that the hexagon should be, the true shape of the base should be. So one of the edges perpendicular. So one of the edges perpendicular to VP. You have to draw the base of the hexagon. Then you proceed. You draw the top view. Then you proceed for the front view or the pyramid. It's a hexagonal pyramid. Then you take the plane. It is cut by a plane which is perpendicular to HP. It is cut by a plane perpendicular. So it's a cutting plane perpendicular to HP 40 degree inclined to VP. 40 degree inclined to VP. So cutting plane is perpendicular to HP and 40 degree, that is 5 is equal to 40 degree inclined to VP. Right. 40 degree inclined to VP. Cutting plane is perpendicular to HP, 40 degree inclined to VP and 10 mm away from the axis and 10 mm away. 10 mm away from axis. So this is about the cutting plane orientation. Right. Cutting plane is, so the cutting plane is going to cut. I am going to have a cutting plane which is perpendicular to VP. This is the orientation I am having. The solid. So I am going to cut the pyramid like this with a cutting plane perpendicular to, this is a cutting plane. Now it is perpendicular to HP. Right. So and at the same time the cutting plane is VP. This is parallel to VP. What is the condition given? It is 40 degree inclined to VP. So it is going to be like this, 40 degree. It is not all the way in the, it is bisecting. How it is? Again 10 mm away from the axis. The axis is going to be in the middle. So from there 10 mm away it is going to cut. It is going to cut. So where I have to show my cutting plane? In which view? Wherever the cutting plane is perpendicular. Where it is perpendicular? It is perpendicular to HP. So in my top view I can see my cutting plane. So I have to show represent my cutting plane as a line in my top view. Then what I will get in my front view? A sectional front view I will get. What about the true shape? True shape you have to separate, you have to get, since the plane is inclined. If the plane is parallel, the sectional front view will hold the true shape. Right. The section whatever you are having in sectional front view, that hold a true shape if the plane is parallel. If the plane is inclined, there will be a separate true shape of section parallel to this plane. Right. That you have to draw it. Is it clear? So now you have to, this is our problem. Draw, full stop, draw the top view, sectional front view, draw the top view, sectional front view and true shape of section. Draw the top view, sectional front view and true shape of section. Right. So first of all you draw the projection. Quickly you draw the projection to this orientation. So resting on HP, base is resting on HP. Base is resting on HP and the base edge is perpendicular. Such that you draw the simple position. First of all, you draw the projection into H. Do it. Listen. Now, the simple position of the solid has I have drawn, that is the front, top view and the front view. So since the axis is perpendicular, since the base is on HP, I have drawn the base on HP, right? Like in the orientation, the edge is perpendicular. The edge of the hexagon is perpendicular to VP. Right, that is the orientation given. You have to draw it like this. Right. Then I have drawn the front view. Listen, now you have to represent the cutting plane. Where you have to represent the cutting plane, you know. I mean, wherever the cutting plane is perpendicular. Cutting plane is perpendicular to HP. So I have to represent my cutting plane in the top view on HP. That is sure. So you have to show the cutting plane here. Now how I have to show the cutting plane? So as a line. So and it is 40 degree inclined to VP and 10 mm away from the axis. In the top view, in this view, where you have the axis is here. That is nothing but in the apex. So this is my axis. This is the location of my axis of the solid in the top view. So from here, 10 mm away, okay, 10 mm I can mark it away and I can draw a 40 degree line. Listen, I can draw a 40 degree line. Suppose I draw a 40 degree cutting plane like this, passing through this 10 mm. What will happen? Is it right? 10 mm away from the axis and it is cut by a plane 40 degree inclined to VP. So if I draw it like this, so the cutting plane, so if I measure 10 mm away from the axis, okay, the 10 mm away in the sense it is not in any direction, it is exactly 10 mm away. So tangentially it has to be 10 mm away. All through from the axis, the cutting plane will pass through 10 mm away from the axis. So what I have to do is, you should not straight away, you should not measure 40 degree and you should not mark 10 mm away from the axis, you should not draw it. That is the wrong one. So what you have to do, suppose if I draw like that, the cutting plane will be like this, it goes through like this. So if 10 mm away from the axis means I can draw it, I can measure 10 mm radius in my compass, I can draw a construction circle, from the axis, that is from apex here. Right. So what is exactly 10 mm away in the sense? From the axis, the cutting plane has to be 10 mm away, in the sense where it has to be passed through. Tangent to this circle, tangentially 10 mm away. So I have to draw a circle, construction circle, 10 mm away from the axis. That is measuring 10 mm radius from the axis. I can draw a construction circle. Then what you can do, you can tilt your drafter to 40 degree. You can tilt your drafter to 40 degree. Right. 40 degree you can tilt your drafter. Now what I can do? I can fix your drafter to 40 degree tilt. Then move your drafter where you have to match it. Tangentially to this circle what you have drawn. 10 mm away circle. So tangent to that I have to keep my drafter and I have to draw my cutting plane like this. See, the previous one is wrong. So the 10 mm away cutting plane, it should be tangentially match the circle what you have drawn. The away circle, 10 mm away distance for a construction circle you have drawn for that. Right. So for that, a tangent line 40 degree inclined to the reference line you have to draw it. That is nothing but my cutting plane. This way you have to draw it. Now 40. You can ask why you have taken tangentially outside. It can be tangent to the other way, right? So I have the 40 degree inclination at two locations. I can have my cutting plane. Okay, 10 mm away. So why I have drawn here? The smaller portion I am looking at here, the sectional view. Suppose I draw a cutting plane like this. The major portion I will be removing off. Okay, smaller portion I will be removing, and I can see the sectional front view. So that I have drawn the. So whatever you are removing for viewing the section, the smaller portion, whatever you are sectioning, that will be removed off. So this is the smaller portion I am removing it off. If I keep my cutting plane here, right? So this way you have to draw your cutting plane tangent to the circle. That is construction circle you have drawn. So neatly represent the cutting plane, that is important. So this cutting plane is at the end, it should be thickened. Both the ends it should be thickened, and it is 40. It is 40 degree inclined to BP. This is 40 degree. So this is how I can represent my cutting plane in the top view. See here, tangentially 10 mm away from the construction circle. Right. So this distance, access to this distance, this radius of this is 10. Right. So to represent the cutting plane, you draw a construction circle of 10 mm radius, that is the away distance. Right. Then for that circle, you keep your drafter tilted to 40 degree, move your drafter tangent to that and draw a cutting plane. Right. Represent a cutting plane like this. Neatly you represent a cutting plane. Right. Whatever portion it cuts the solid, inside to that solid it should be continuous. Outside you have to represent the cutting plane representation, right? That is axis line at both the ends, it will be thickened, right? Now, then once it's over, what I have to, listen all of you, once it is over, what I have to do it, I have to mark the cutting points, right? Cutting points you mark it, see here, I can mark the cutting point, listen all of you, I can mark the cutting points from one left extreme to searching for the visible cutting points. How many cutting points I will have? I am having here. See here, it cuts the base here in the extreme. It cuts the base here. So that is my cutting point 1. That is my cutting point 1, isn't it? This is my cutting point 1. Then it cuts the slant edge immediately next. You move along the cutting plane. Listen, you move along the cutting plane, searching for the visible cutting edges. So I have, it cuts the base edge 1, then it cuts the slant edge OA. So that is my cutting point 2. So I am moving along the cutting plane. Then it cuts the slant edge OB. So OB, that is my cutting point 3. Then again you move along the cutting plane. It cuts the base, again a base edge. That is my 4. So I have 4 cutting points here. Right. So these 4 cutting points have to be projected in the front view. Right. So I don't have, again you come back to the original location searching for hidden cutting points. I don't have any hidden edges in the top view. Right. So I have only 4 cutting points. Now just I project these cutting points to the front view. So 1 and 4, where I have to mark it. So cutting point 1 and 4, it is on the base edge. In the front view, where you have base edge? On the reference line. Right. So 4 will be exactly, I will be getting here 1 exactly at A. Right. So my cutting point 1 is here. That is 1 dash. Cutting point 4 dash is this. Right. Then this 2 and 3. Listen all of you. This 2. How I can project it? 2 cutting point is back. AO. It is at AO. So AO slant edge. So AO slant edge, the 2 cutting point can be projected vertically to the front view to the projector line. So where I have OA, AO slant edge I have here in the extreme, AO. Wherever it meets AO in the front view, that is my cutting point 2 dash. Right, here, cutting point 2 on AO, right. Then what about 3? Listen all of you carefully. This 3 cutting point is OB. So where I have OB in my front view, it is exactly in the middle. Listen all of you, listen. So OB is in the 3 slant edge. Cutting point 3 is on slant edge OB. Suppose I project this, vertically project this, it will be it doesn't meet the OB since both are in a vertical line. So how I can transfer this cutting point 3 to OB slant edge in the front view? Anybody, how I can transfer that? So what, there is a process, see here, so this cutting point is directly projected to OA, since it is a slant edge. Here it is not able to project that, since both the slant edge in front view and top view, it is falls on a single projector, right? So see here, this 3, what I can do is, this distance, O to 3 distance, I will mark it on any other slant edge. Okay, in any other extreme slant edges, O3 distance, I will mark it to, say, I will mark it to OC. So O3 distance I am marking it to OC. So this is an arbitrary location, so I can mark it as 3, 1. Right, 3 dash. So just I am rotating this, or I am marking this to another slantage or extreme slantage. Right, another slantage 3, OC. Now this I can be projected to OC. So OC is a slantage in the front view. Right. So this 3, 1. This 3, 1 can be projected to the corresponding slantage. What is that slantage? That is OC. It is projected to OC. Here I have in the extreme. That is my 3, 1 dash. So this is not my actual cutting point. Where I have to mark this cutting point? Actually the cutting point is on OB. The cutting point is on OB. So I have to mark the cutting point in my front view on OB slantage. So how I can transfer this to OB slantage? Just you project this to horizontally, you project this to OB slantage. So this is the location, actual location of 3 dash. Is it clear? See here, cutting point since it falls on a single projector, okay, in both the views, so this cutting point has to be transferred to another slantage, okay, inclined slantage. That slantage, that cutting point will be projected to that corresponding slantage. From that, it will be extended to, projected to the original slantage OB. Similarly, if I have a cutting plane here, cutting point here in the middle, if I am not able to project it, what I have to do it, I have to extend to another slantage, then I can move to the top view and I can rotate it to the corresponding slantage in the top view. The same procedure you can follow it, right? So this is the way you have to project the cutting point which falls on a same projector line in both the views, right? Now my cutting point, actual cutting points are, so you mark this as in light, mark it up, 1, 3, 1, this is 3, 1 dash. Now my cutting points are 1, 2, 3 and 4. You join that in a sequence. So 1, 2 is this, then 2 to 3, then 3 to 4. Right. This is my section. So this I have to hatch it. You hatch this. Right. That is the sectional front view. See here. Listen all of you. Listen, once I have removed this part, so which is the retained portion in my top view, I have removed this front portion. This portion is my retained top view. So that alone you have to alternate. Retained top view alone. You have to alternate. Then showing the slant edges also. The retained slant edges. Right. So this is my retained top view. Right. Then this is my sectional front view. Sectional front view. So once I have finished this section alone. Right. Apparent section. So the remaining portion also you have to show in your front view. The remaining portion is there. That also you should document. See here, one more thing, still it is not, the sectional front view is not fulfilled. How I have to draw this? What is missing? Once I have removed this, which portion I can see? This portion I will have one more edge, slantage. What is that? OE. I have here OB and OE. I have this point in the middle, OB and OE. Right. So OB is removed, partially it is removed. I will have OE, that is hidden. OE slantage is hidden. That will be shown in the sectional front view as a dotted line. So this portion will be shown as a dotted line. So the sectional front view is fully finished. Right. Then you move on to your true shape of section. How I can draw the true shape of section? Draw a reference line parallel to the cutting plane. Draw a reference line parallel to a cutting plane. See here, parallel to this. Listen all of you. Listen all of you. To draw the true shape using reference line procedure, you will be drawing a new reference line parallel to the cutting plane. Okay, parallel to the cutting plane, and you will be extending projectors perpendicular to the new reference line from all your cutting points. That is 4 cutting points. You can extend 4 projectors, that is a perpendicular projectors to x1, y1, new reference line. Then you have to mark the apparent section cutting point distances from the old reference line xy. So from xy, where I have the cutting point, that is cutting point 1 is on the reference line itself, right? Old reference line itself. Similarly, 4 is on the reference line itself. So I can conveniently mark from 1, the cutting point 1, I can mark it on the reference line itself. That is my cutting point 1. Cutting point 4, it is on the reference line itself, I can mark it. Right. What about cutting point 2 in an apparent section? From the old reference line, what is this distance? You measure. Okay, this distance you transfer it to from the new reference line from cutting point 2. Whatever projector you have extended from cutting point 2, that you have transferred it. This is my cutting point 2. Right. Similarly, cutting point 3 distance from old reference line. This distance you measure. From cutting point 3 you have drawn a projector. On that projector from the new reference line, you mark that cutting point 3 distance. Right. Actually 2 and 3 is coming very closer. Right. By joining this, that is with a straight line, this will be my true shape of section. So then you hatch this. Listen. The solid here I have kept in which orientation? Look at the solid. It is lying on its rectangular face on the ground. How it is lying? How the axis? Axis is perpendicular to it. This is the orientation. You have to draw the projection for this. Take the problem here. Hexagonal prism. Pentagonal prism of base side. Pentagonal prism of base side. Pentagonal prism. Base 30 mm you keep it. Then height 70 mm is lying on the ground with one of its rectangular side face. Lying with a rectangular face. Rectangular face. Lying with a rectangular face such that the axis is perpendicular to VP. Axis is perpendicular to VP. It is not inclined, right? This axis is perpendicular to VP. Then the plane, cutting plane. It is cut by a plane. It is cut by a plane like this. What is this orientation? Tell me. It is cut by a plane like this. Perpendicular to HP and inclined to VP. Same condition. Inclined to VP. Right. So that inclination I am going to tell. Then where it is exactly cutting the solid, that I am going to give. That is exactly bisecting the axis. So it is cut by a plane. Take it. It is cut by a plane which is perpendicular to HP and 40 degree inclined to VP. It's cut by a plane perpendicular to HP, 30 degree inclined to cutting plane perpendicular to HP, 30 degree inclined to VP, that is VP inclination, right? 30 degree inclination, and bisecting the axis. Bisecting the axis. Bisecting the axis. Full stop. Now, what view will get first of all? Sectional. What view? This view is top view. Top view. Then what view? Front view will be a sectional view or sectional front view or. So this is in this orientation. I have to draw top view. Then I have to get it sectional front view. Then I should get a separate true shape. So you take the problem, draw the top view, sectional front view and true shape of section. Draw the top view, sectional front view and true shape of section. Right. Now you tell me where I have to represent the cutting plane, in HP or VP?
VP. Inclined to
correct. Where I have to represent the cutting plane? HP. Since the cutting plane is how? Perpendicular to HP. So I have to represent the cutting plane on HP. Since the cutting plane perpendicular to HP, I have to represent the cutting plane on HP. That is nothing but my top view. Right. Then you have to move on for your sectional front view, then true shape. Right. So you draw the projection first of all. Quickly you draw the projection. Where I will have my base. It is on BP. Since the axis is perpendicular, how I have to draw it? The pentagonal base, true shape, it will be resting on the, one of the side will be on the reference line. Then you project the top view. Listen here, once I have cut the solid using my cutting plane, I will be cutting like this, I will be removing. So my sectional front view will hold the cross section. Hold the cross section. Right. That is going to be my sectional front view, and I will be getting your top view. Right. Top view, sectional front view, and the true shape parallel to this you will be obtaining. You will be drawing. So quickly draw the projection. See here. Right. The simple question I have drawn. So since it is lying, base will be seen on VP, axis perpendicular, and base is seen on VP with a rectangular face on the reference line. Right. This way you will be drawing front view. You have drawn the top view. Right. You neatly represent the cutting points and the hidden lines. Okay. In the top view you can see two hidden side edges. Right. Then as for the cutting plane representation, since the cutting plane is perpendicular to HP, I have to represent my cutting plane on HP. So I have shown the cutting plane here, and the cutting plane inclination is 30 degree, and it is exactly bisecting the axis. That is bisecting the sense axis height is 70, so bisecting, that is 35, exactly in the middle of the axis, that is 35 location from a base. Then the cutting plane is 30 degree inclined, I have represented. The cutting plane neatly you represent it. All through the solid you have to show it as a visible continuous line. Then extend outside to end. Both ends of the axis line has to be thickened. In two lines you have to thicken this both ends. Right. So this is the representation of the cutting plane. Then marking the cutting points from the left extreme corner, you mark the cutting point. Suppose this is a cutting point. How many cutting edges, slant edges it cuts? This cutting plane, how many side edges, not slant edges, side edges it cuts? How many side edges it cuts, this cutting plane? 5. So it cuts all the 5 side edges. So how many cutting points I have? It has to hold 5 cutting points. So each edge it cuts, I will have a cutting point there. You see, from the left extreme, so it cuts a side edge PA side edge it cuts. So I can mark the cutting point 1. So this is my, listen all of it, listen carefully. This is my cutting point 1. This is my cutting point 1. It cuts the visible side edge PA, right? Then you go along the cutting plane looking for the visible cutting point first of all. What is the next visible cutting side edge I have? Next visible side edge I have along the cutting plane I have TE. TE is my visible side edge. So there I will get my visible cutting point 2. Right. Then you go along the cutting plane looking for the visible cutting point and visible cutting edge. So visible cutting edge is SD. So there I will have my cutting point 3. Then you come back to your original location searching for the hidden cutting points. So searching for the hidden cutting points. It cuts the hidden side edge, that is RC. So there it will hold cutting point 4. That is my hidden cutting point. So put it inside bracket. Right. Then you come back to the original location on the same manner searching for hidden cutting point. It cuts a hidden side edge, that is QB. So that is my cutting point, hidden cutting point 5. So totally I have 5 cutting points, 3 visible cutting points, 2 hidden cutting points in the top view. Then you project this to the front view. So you look at these cutting points. These cutting points are cutting this side edges. So as for the front view, where you have the side edge PA, where you have the side edge PA, it is seen as a point here in my front view. The side edge PA is seen as a point. So my cutting point also will be on that point itself. So by projecting this one, my cutting point also I will be getting it here on the edge itself. So similarly cutting point 2, it is on TE. So TE I have here. So my cutting point 2 also it will be here at this location. So since this side edge is seen in the front view as a point, so cutting point also will be fall on that point, right? Side edge. Here I will have my cutting point 3. Then here I will have my cutting point 4. Here 5. If you want neatly, I can. So my cutting point 1, 2, and 3, 4, 5. These are all with the dash. S and T. Right. This way you can show it. Then listen. Then getting the true shape. Now this is my cutting points in the front view. By connecting the cutting points in sequence 1 to 2, 2 to 3, 3 to 4, and 4 to 5. Right. That is going to be my section. Right. Apparent section. Just you have to match that. This is my sectional front view. This is my sectional front view. So what about my top view, which is the retained portion, my top view? The front portion is removed. So the retained portion is this. That alone you have to darken it. The retained portion. Right. This is my retained top view. This is my sectional front view. Then you go for the true shape of section. Listen. True shape of section will be obtained by drawing a new reference line parallel to the cutting plane. If you have space here parallel to the reference line, I can draw it. I can extend my cutting points perpendicular to this. I don't have space here. What I can do it? I can draw a new reference line parallel to this somewhere here. Right, and I can extend upward also. Wherever you find space, you draw the reference line. Right, your drawing sheet. Now I have a space here above the, so parallel to this cutting plane, I am drawing a reference line. New reference line. So this is my X1, Y1. Right. Then you extend projectors from cutting point perpendicular to this. Right. Now you just transfer the distances of the cutting point from the old reference line. The cutting point distances you measure it from the old reference that is xy. What is the cutting point? One distance is this. This you can measure it. That I can transfer it here. Right. This is my cutting point 1. So from the new reference line, I have to transfer it. Similarly, 2. 2 is the distance here. Right. From here, cutting point 2 is in this projector. I will mark 2. So cutting point 3 is here. The same distance of 1. So this is my cutting point 3. Cutting point 4 and 5. On the reference line, it falls on the reference line of old reference line, the new reference line, cutting point 4 from the new reference line, again it falls here. That is my cutting point 4. Here my cutting point 5. Right. So just by connecting this cutting points in sequence in the true shape. This is my true shape of section. Just you can ask that. Take the problem. A cylinder of diameter 50 mm and height 70 mm. A cylinder of diameter 50 mm and height 70 mm. Lying on the ground, with one of its generators, such that the axis is perpendicular to VP. What is this orientation? The axis is perpendicular to VP. This is the orientation. Okay. You have to draw the projection for this, where you will have the base circle on VP. So touching the reference line, you have to draw the circle. Draw the circle first of all, then draw the reference line touching tangentially to that, right? Then you get the projection top view. Divide the circle into 12 divisions. It is cut by a plane which is perpendicular to HP and 65 degree inclined to VP. 65 degree inclined, cutting plane perpendicular to HP. 5 is 65 degree inclined to VP. Right. 65 degree inclined to VP. Meeting the axis 10 mm. Meeting the axis 10 mm from the front base. 10 mm from the front base. 10 mm from front base. So you see which is your front base here? Front base. This is the front base. Okay, nearest base. 10 mm from the nearest base I can say, or I can have it as 10 mm from the nearest base. To you, 10 mm from the nearest base. Right. So this is the nearest base for you. This is the farthest base for you. Right. Suppose the solid, same solid is like this. 10 mm from the, I can say this is the top base, this is the bottom base. So this is the top base circle, this is the bottom base circle. Now the solid is here. So the position of the cutting plane is given 10 mm from the nearest base. So this is your nearest base here. From that 10 mm on the axis, you have to mark the point. Then you have to represent a cutting plane that is 65 degree inclined. Right, 65 degree inclined, you have to represent the cutting plane. So the cutting plane orientation is given. So as for this case, where you have to show the cutting plane. Cutting plane is perpendicular to which plane? HP. So HP I have to represent my cutting plane, that is on top view I have to represent my cutting plane. Then I have to draw a top view, what front view will obtain? Sectional front view will obtain. Okay, top view, sectional front view, and since the plane is inclined, you should get a separate true shape of section. So draw the top view, sectional front view, and true shape of section, you have drawn the front view and top view, right? You notate the two bases in letters, right? Why? Because the cutting points will be notating it in numbers, right? So two base, so I have divided into 12 divisions, so totally 24 letters you should have. So starting from A, B, C, D I have given one base, starting from M I have given marked as another base, right? So the A, B, C, D base in the top view is hidden, so MN base is visible. The MN base is my nearest base. For you, this is going to be the nearest base in this orientation, right? Lying orientation. MN base is the nearest base. Now, so the projection you have drawn, only you show the axes and the generators in the top view, right? Then the cutting plane you have to represent it. See the cutting plane data is this. The cutting plane is perpendicular to HP. So I have to represent the cutting plane on HP, that is on top view. So I am representing the cutting plane on top view. And the orientation is given 65 degree. So it is 65 degree inclined to VP. Right. Then it is 10 mm from the nearest base. The nearest base is MN base. From there it is 10 mm. It is meeting the axis at that location. And it is 65 degree inclined. So I have represented my cutting plane in the top view. Right. Now, notating your cutting points. Listen carefully. Notating your cutting points. So cutting point you start from the left extreme. Okay, searching for the visible generators it cuts. Right. Then you come back on the same manner, searching for the hidden generators it cuts. Right. So here you see, at the extreme I will have only one generator. Nearest to that, next to that I will have two generators. One is visible, one is hidden. Then next I will have two generators. One is visible and another one is hidden. Here in the middle also I have two generators. One is visible and hidden. Then immediately next it is hidden. In this orientation it doesn't cut another generator. It cuts the base, nearest base. Right. As I told earlier, if the cutting plane cuts the base of the solid, you will get how many cutting points? If a cutting plane cuts a base, any base, you will get 2 cutting points on that base. So if it cuts one base, 2 cutting points on that base you will get. If it cut 2 base, you will get 4 cutting points totally, right? If a cutting plane cuts a base of the solid, definitely you will have 2 cutting points. You have to mark 2 cutting points on that base. Is it clear? Now, we will give the cutting points in the order. From the left extreme, I am marking the cutting point 1. That is my visible cutting point. Right? I am marking the cutting point 1. That is my visible cutting point, which cuts the generator what? MA. Cut the generator. Listen all of you, MA. Then you go along the cutting plane, it cuts the visible generator, which is like visible generator. See, listen. The hidden points I will mark it. Right. The hidden points I will mark it. This is my this is my B, C, D, E, and F. Here, visible point N, O, P, Q, R. Right. So see here. Next, it cuts the visible generator XL. XL generator it cuts. So there I will have the visible cutting point 2. Right. Then you go along the cutting plane, it cuts the next visible generator, that is WK. There I will get cutting point 3. Then you go along the cutting plane, it cuts the middle generator, that is visible generator VJ. So that is my cutting point 4. Then immediately it goes to the base. There I will have 2 cutting points. One is visible, that is 5. Another one is hidden. on the same base itself, that is my 6, right, that is hidden 6 on the base itself. Then you come back on the same manner along the cutting plane, searching for hidden cutting points on hidden generator. So 6, then I have immediately here a hidden generator PG, that is my cutting point 7, that is hidden. Then here I will have another hidden generator OC, that is my cutting point 8, which is hidden. Then I have another hidden generator, that is NB, that is my cutting point 9. So again, in the extreme, do you have any hidden generator? Only one generator in the extreme, that is your visible generator already given cutting point. So totally how many cutting points you have? 9 cutting points. These 9 cutting points you project to the front, to your front view. Now, in your top view, which is your retained portion, once I will be removing this, cut this solid, I will be removing this portion. The retained portion alone you have to document. The retained portion is this. This is the retained cylinder I have. Only I can see the periphery. So inner generator should not be documented. Right. This is my retained cylinder. Now, the sectional front view you have to go. Right. So these cutting points 1, 2, 7 and 4 except 5, 6 all are from cutting points we are getting from the generators. Right. So these cutting points will be exactly marked on the corresponding generator points in the front view. So one is on generator MA, where MA is generator is seen as a point in the front view. So that is my cutting point 1. Then this XL cutting point is this. So on XL I have cutting point 2. So 2 dash is a point this. Similarly 9, there is a visible hidden cutting point, that is NB. So NB is here, that is my 9. That. Similarly you go along this 2 dash, this will be my 3 dash. This is my 4 dash. Cutting point in the front view. Then 5 is on the base. Right. Here 5 and 6. Then go to 7. 7 is on PD. So PD is this. This is my 7. Cutting point 7 dash. This is going to be my 8 dash. Right. What about this? How I can mark this 5 and 6? It is on the base. Base is seen as a circle in the front view. Right. So this 5 and 6 I can project it directly. I can project it to the front view. Wherever it cuts the circle in the front view. So where it cuts the circle in the front view, that is my what cutting point? 8. Similarly, wherever it meets the top portion of that circle, the other side of the circle, right? So wherever it cuts the circle, that is my 5. Cutting point 5 dash. This is my cutting point 6 dash. So this is my cutting point 5 dash and 6 dash. Right. By joining these cutting points in a circle, I should join it in a straight line or curve. In a curve, as a curve I have to connect these cutting points. As for cylinders and cone concerned, whatever cutting points you are connecting, it should be in a curvical manner. Right. Other than cylinder and cone, that is prisms and pyramids, you will be connecting the cutting points with straight lines. Here for cone and cylinder, you have to connect the cutting point, join the cutting points in a curvical manner. Now, starting from 1 to this, it will be a curve. How I have to connect this cutting point for 5 and 6? It cuts the base here. It cuts the base. Right. So it will be connected as a straight line. 5 to 6 will be connected as a straight line. So this is going to be my apparent section in my front view. So just you can catch this apparent section in the front view. Right. This is my sectional front view. You see here, the section I have drawn in my front view, the retained projection also I have to show it. Okay, after sectioning I can see this portion of my front view, right? This base of my front view, right? In front view. So Right. This is my sectional front view. To move on to your true shape of section, drawing a parallel reference line to your cutting plane, either wherever you find space, either below or above. So wherever you find space, you draw a parallel reference line, new reference line to draw your true shape of section. So this is my new reference line. Y1. Listen, how I can mark the cutting points, transfer the cutting true shape, how I can obtain the true shape. So you transfer the cutting point distance, apparent cutting point distance from the old reference line to the new reference line. From the old reference line XY, so what is the distance for 1, cutting point distance for 1, you measure that you transfer it from projectile 1 and mark that cutting point 1. So this is my 1. Similarly 2 and 9. 2 and 9, I can mark it. 2 and 9. 2 and 9. 3 extreme generators. Parallel to extreme generator. Extreme generator. Parallel to one of its extreme generator and 10 mm from it. 10 mm away from it. 10 mm away from it. One of its extreme generator 10 mm away. Right. So this is about the cutting plane. Full stop. Draw the, so which view you will get. So it is cut by a plane perpendicular to VP. So I have to get a front view. Okay. Draw the front view, comma. So what kind of view you will get? Top view. Sectional top view, comma, sectional top view. Then true shape of section. See here, the cone is resting on the ground with its base. So my top view, axis is perpendicular to HP. Top view will be a circle. Front view will be a triangle. Right? You divide the circle into 12 segments. Notate the points, base points. Right? Then the front view, you mark the same notations in the front view. Apex, then you try to show the generators in 2H pencil. All the 12 generators you try to show in your front view in 2H pencil. Because we are going to get a cutting points on the generators. Where the cutting plane cuts the generator, there we have to mark the cutting points. So you try to show the generators in the front view also in 2H pencils. Don't darken it. Then representing the cutting plane. Cutting plane position is given, it is perpendicular to VP. So where I have to represent on VP, I have to represent the cutting plane. Right. So in front view, I have to represent the cutting plane. Then it is parallel to one of its extreme generator. Which is extreme generator? Here I have, that is AO and GO. So either AO, parallel to AO or parallel to GO, I can draw a cutting plane parallel to that at which location? So what distance apart? 10 mm away from that. So I am using the generator GO parallel to that, 10 mm away from that. I am drawing a cutting plane, representing a cutting plane that is 10 mm away from that. So this is my cutting plane represented in the front view since it is perpendicular to VP. Then giving the cutting points, notating the cutting points, listen, from here you can start, right? Or from here you can start. Or either this cutting plane can represent parallel to this AO generator. It's up to you. So I have made it parallel to GO. Right? So I am giving the cutting point notation. Listen, from starting from the bottom I am giving, searching for the visible cutting edges. See here, I am giving the cutting point 1. So the cutting plane cuts the base of the cone. So how many cutting points on the base I will get? Two cutting points. One is visible, one is hidden. So first of all I am giving the visible cutting point 1 on the base. Right. Then you move along the cutting plane, searching for the visible generator it cuts. Visible generator here is IO. IO it cuts. Wherever it intersects IO generator. So that is my cutting point 2. Then visible cutting point on the visible generator, DO is cutting point 3. Then visible front view cutting point. Then searching for the visible cutting point on the visible generator, CO, that is my cutting point 4 dash. Then again along the cutting plane it cuts another generator, visible generator, that is BO. There I will get a cutting point 5 dash. Then it cuts again moving along the cutting plane. It cuts another extreme generator. That is only one visible generator. That is AO. So there I will have cutting point 6 dash. So it cuts 5 visible generators on a base. Right. Then it cuts 4 hidden generator. So come back on the cutting plane. Okay, searching for hidden cutting point. Then it cuts the hidden generator, LO, so that is my cutting point 7 dash. So that is my hidden cutting point. So you can mark it inside bracket. Then it cuts the hidden generator again along the cutting plane K. the base again. So that is a hidden base point. So that is my 11 dash. So 1 dash and 11 dash on the base, remaining cutting points, 9 cutting points on the generator. 5 of them are visible cutting points, 4 of them are hidden cutting points. Totally it cuts 9 generators and a base. Totally 11 cutting points. If it cuts a base, I will get 2 cutting points. Similarly, it cuts the generators totally. So how you in an order you look for a hidden cutting point, then come back on the same manner looking for the look for the visible cutting point, then come back on the same manner searching for the hidden cutting point. So totally I have 11 cutting points. These cutting points has to be marked in my top view, projected in my top view. So the generator cutting point, this is something like a pyramid, so it is a cone. So in these generators will be seen as a line in the top view. So carefully you get these cutting points, transfer these front view cutting points to the top view. So you see, look at this, the extreme cutting point is 6. 6 is on which generator? AO. Right, 6 is on AO. Just I am projecting AO vertically, cutting point 6, vertically to the top view. Listen carefully, listen. So where I have AO here in the top view, this is my generator AO in the top view. Where it meets that generator, that is my cutting point 6. Right. Then I have Y and 7 together on generator BO and LO. Listen all of you, on generator BO and LO. So this Y and 7, so that cutting point can be projected parallelly to the top view. So wherever it intersects BO and LO. On BO I have to mark 4 visible cutting point. On LO I have to mark hidden cutting point 7. So BO is here. I have B to O. So that is my visible cutting point 5. Visible cutting point 5. So then 7 is on LO. L and O is here. So this is my 7 cutting point 7 in the top. Right. Then similarly 8 and 4. 8 and 4 I can project it to the top view. Right. Wherever it cuts, 8 and 4 is on KO and CO. So CO, wherever it cuts, that is my 4. So LO, so KO, wherever it cuts, that is my 8. Right. Then this 3 and 9. Listen carefully. Listen carefully. This 3 and 9, how I can transfer it? 3 and 9. 3 and 9. 3 and 9 is on which generator? JO and DO. You see here, already we have seen, if a circle I have, so the generator is, that is my, which is my generator? This is O, this is my D, this is my J. So in the front view, the cutting point is somewhere here. The cutting point, so the generator in the front view is DO and JO is this. Right, my cutting point 3 and 9 is here in the generator vertically. How I can project it to the top view? Is it possible? It is lying on the same projector. I cannot mark it. I cannot project it similar to the previous point. Right? Slant generator. This is a vertical generator I have in both the views. Right? So how I can mark this? This 3 is on visible one, 9 is on hidden one. That is hidden generator is my J. Right? How I can transfer it to OD and OJ. So just what I can do there, the other problem I have done, just to project it to this other generator, slant generator, that is otherwise the extreme. Listen all of you, otherwise to the extreme. So just 3 and 9, we extend to the another extreme generator. Okay, I have a generator here, what is that? A. to AO. This is my 3191. Right. So just you project this to corresponding. Now this 3 and 9 is on which generator? AO. So here I have AO here. So this location I can mark 3 and 9. Now how I can transfer this to this original generators? So just you measure this, just you rotate this, just you measure it and rotate it to the corresponding generator. So here I will have my what point is on OD, I have to mark it on my 3. My OJ I have to mark my 9. So this is how you have to transfer this cutting point 3 and 9 which is on the vertical generator, which you have on the vertical generator. Right. If it is on slant generator, directly it can be projected to the top view. Since it is on a vertical projector, okay, so I have to transfer that to another extreme projector or slant projector. So that you have to project it to the corresponding slant projector, that is an extreme projector. From there you have to measure the distance from the apex, you have to mark it on the exact appropriate, that is generators, right? Generator, and you have to project it to the generator and to the appropriate generator. Now 3 and 9, so what I have to do is I am projecting it to the extreme generator horizontally, then that location I am projecting it vertically downward to AO generator. So this is the location AO. Right. So this location go to A and to be rotated. That is on the slant generator, right? I can straight away project it. Straight away I can project it. So this is my loop. This is my 10. Listen. Then all the generator cutting points have transferred. What about base cutting points? Base cutting point is 1 and 11. So it should intersect the circle. It should intersect the circle, base circle. So just project 1 and 7 cutting point. So wherever it meets this circle, that is my base cutting point. This is my 1, this is my 7, sorry, 11. Right. Carefully you transfer this. By connecting, listen, you have to show the retained front view and sectional top view. The retained front view is again a triangle. So this is a cutting plane. So the remaining portion of the front view of the cone should be shown like this. Only the extreme generator should be darkened. Only the extreme generator should be darkened. Then similarly your sectional top view. What is this section? First of all, how I have to connect the section as a curve, I have to connect it. So connect this cutting point as a curve first of all. just to hatch that. So this is our apparent section. Which is the retained sectional top view. Retained portion is this portion of the cone is removed out. So retained portion is the circle, base circle. So this is my retained portion. Once you have got the sectional top view design, the same manner you draw to get the true shape, you draw a parallel line. That is a new reference line parallel to your cutting plane. See here, this is a cone. What is a conic section? What we have seen in the first unit itself. Okay, cone is cut parallel to a generator. What will be the true shape of the generator? True shape of the cut surface. So cone cut parallelly to one of its generator. What curve you will obtain? If a cone is cut parallelly to one of its generator, what kind of curve you will obtain? Ellipse or parabola or hyperbola? Parabola. So the true shape of the cut surface will give you a parabola if the cone is cut parallel to one of its generator. So parallel if I look at the cut surface perpendicular to that, the true shape will be a perfect parabola. Right. Similarly, in cone you may get a problem if a cone is cut inclined to its axis. What kind of true shape you will get? Inclined to its axis. If I cut a cone like that, I will get an ellipse. Right? I will get an ellipse. If I have a cone, listen. If I have a cone, you know, already you know, axis is here. If I cut a cone inclined to its axis, the true shape of the cut surface will be an ellipse. Right. So it cuts all the 12 generators, you will get 12 cutting points. So 12 cutting points, if I project into a true shape, if I get a true shape, that will be a perfect ellipse. Here, since it is parallel to an extreme generator, the true shape will be a parabola. So you have to get a parabola here. This is my parabola. True shape. True shape is a parabola. So in this orientation, true shape is parabola. So here, the true shape will be an ellipse. So you may get a problem like this. Cutting plane which cuts all the generators, that is the inclination will be given. The location of the cutting plane will be given. The true shape will be a parabola. But apparent shape will be a different one. It won't be a parabola. It will be a different apparent section you will get. Here, the problem drawn here is fully finished. Can you tell me the problem for this? Right. What is the solid, how it is oriented? What is the solid, how it is oriented? Describe the solid and how it is kept. Cone off. Take the problem here, cone off. We'll be giving the problem. A cone of what? Base dia. Cone of dia. Base dia. 60 mm. And height 60 mm. Resting on the ground with its base. Right? Take the problem. The cone of dia 60 mm, height 60 mm is resting on its base, is resting on the ground with its base. Right? Is it clear? So this is about the solid. I have drawn the projection for the solid similar to the previous problem. Since it is resting on its base, the base will be shown on HP and front view will be a triangle. I have divided into 12 divisions. I have got the points in the front view as well as I have shown the generators of 12 generators. Right? Then cutting plane. Right? Cutting plane. Tell me me. Cutting plane, you define the problem. Cutting plane is in which plane? HP, right? Cutting plane is perpendicular to HP. Take the problem. Cutting plane is perpendicular to HP. Perpendicular to HP. Since I have shown the cutting plane on HP, then how it is inclined? How it is inclined? 45 degree inclined to 45 degree inclined to which plane? VP. Any inclination on top view, I will show it will be the inclination of VP. So 45 degree inclined to VP. So cutting plane is perpendicular to HP and 45 degree inclined to VP. Right. Then where it is exactly going? Away from 10 mm away from the axis. 10 mm away from the axis. This problem defines like this. Cutting plane is perpendicular to HP and 45 degree inclined to VP and it is 10 mm away from the axis. So you have to draw a 10 mm circle, radius circle, then tangent to that 45 degree inclined cutting plane you have to represent like this. So and it is 10 mm away from the axis. From axis. Right, this is about cutting plane. Then what you have to draw it? Draw the, is it front view? Draw the top view. This is front view, sectional front view. Draw the top view. Come on. Sectional front view. Then true shape of section. Draw the top view, sectional front view and true shape of section. Listen all of you. Listen. This problem as it is drawn, cutting plane is represented in the top view. So you see here, it cuts the base. So base, I will have two cutting points, 1 and 7 on the circle. Then it cuts the generator. Starting from here, I am rotating the cutting point. 1, it is on base. It cuts the circle, 1. Then it cuts the generator DO. That is cutting point 2. Then it cuts the generator CO, cutting point 3. Then it cuts BO, cutting point 4. AO 5, then LO 6, then it cuts again the base, that is 7. So totally 7 cutting points in the top view. This should be projected to the front view to get the sectional front view. So which is the retained portion? This is going to be my retained top view. Then these cutting points are projected. You see here, 1 and 7 on the base. 1 is projected to the front view here. This is my cutting point 1. So 7 is on base. So 7 on base, it is projected. Then cutting point 2. You see, cutting point 2 is on D. OD. OD is a vertical generator. How I have to project the cutting point? What I have to do it? Similar to the previous problem. OD, cutting point 2 is on OD. This cutting point 2 distance has to be rotated to an extreme generator. OG. So it is rotated. So my 2, 1. This should be projected to the OG here. Right. This is my 2, 1. OG generator. Then it is horizontally transferred to OD. Right. So this is going to be my cutting point 2 on exactly OD. Right. You are getting 6 points, right? Oh, no problem. Leave. So this is, I have here 1, 2, 3. So 3, cutting point 3 is on OC. Right. OC should be directly, it can be projected. These are all slant cutting edges. Okay. Slant generator, sorry. So these cutting points are directly projected to, this is my 3. This is my 4. This is my 5 extreme. This is going to be my 6. Then 7. So by joining this with a curve and a straight line, I will have my section, that is apparent section. So this apparent section has, then the retained front view has to be darkened. So this portion is removed. So I cannot see this portion of my front view cone. So then the retained portion is tangent to this. So a triangle will be seen in my front view. So this is my retained sectional front view. Then you can go for your apparent section. So apparent section will be it is parallel to the axis and it cuts, you will have which true shape? Sorry, which is your true shape? It will be parabola or hyperbola? Hyperbola. You will get a hyperbola. It cuts parallel to the axis and the incline. You will get a hyperbola. Right? You transfer these sectional points to the true shape. You will get a hyperbola. So this is my cutting point 1 and 7. So 1 and 7. So these points, if I project it, so I will have a cutting point maximum of this. Is it clear? So the section plane, cutting plane is in the top view. It is perpendicular to HP, right? And it is inclined 45 degree to VP. So I will get sectional front view and true shape of section as a hyperbola. To do it, we'll start. We'll continue section of solids. Okay. We have been sectioning a cone. Okay, in different locations by a cutting plane, right? Cutting plane can be perpendicular to HP or BP. So the last class we have seen a cone, it's cut by a plane perpendicular to HP and parallel to one of its generator. So the true shape we have obtained was what? If a cutting plane cut a cone parallel to its generator, the true shape obtained was, last class, it is parabola. If it is parallel to one of its extreme generator, then the true shape will be a parabola. If a same cutting plane, perpendicular cutting plane, cuts the cone inclined to its axis, okay, then what you will obtain? Suppose I have a cone like this. If it cuts by a cutting plane in this manner, what will be the true shape? True shape you know, right? It is an ellipse. Ellipse you will obtain as a true shape. This they have seen already. Right. So all the generator it cuts, you have to draw the sectional top view. So it will be an apparent section. This is a true shape. The true shape will be a ellipse. Similarly, if I have a cone, last class we have seen a cone cut by a cutting plane perpendicular to HP. So it was something like this, inclined like this. The apparent section we have got in this manner. Okay. The true shape. The true shape we have got. What will be the true shape we have got? The true shape we have got, since it is cutting parallel to its axis, right? We will be getting parallel to its axis. We will be getting a hyperbola. It will be a rectangular hyperbola we have obtained. This is a rectangular hyperbola we have obtained in this class. Right. Rectangular hyperbola. The last class we have seen this. Similarly, if a cone is cut, the same cone. Okay, these problems you should remember. So what is the true shape we will obtain? So you have to represent the cutting plane, you have to mark the cutting points. As usual, you have to proceed it. You have to get the front view, sectional top view, or sectional views and the true shape of section. Suppose I have a cone like this. Already you know, if I am cutting a cone passing through its apex. What is this? Apex. Passing through its apex. What will be my true shape? What will be my true shape? First of all, you tell me how many cutting points I will get for this. 3 cutting points. So it cuts the apex, goes through the apex, so there I will have one cutting point. And it cuts base, two cutting points. It doesn't cut the generator. The cutting plane itself, it's aligned with the generator. Okay, that it won't cut a generator at all. So totally I will have three cutting points. So what will be my true shape? What will be my true shape? If a cutting plane goes through an triangle, isosceles triangle, we getting a isosceles triangle as my true shape. So I will have only three cutting points. Right. So this is the one you should remember. Right. You have it. This is an isosceles triangle. Triangle you will have take. Right. So you want a problem in this? So you will have it, you do it at homework, okay, after finishing the lecture you can do that. Right, this problem I will give it, because otherwise you make a note of problem of this, you do it on your own, in the third hour you can do this. Yeah, cone of base diameter, cone of base diameter 50 mm, height, that is altitude is 60 mm, is resting on the ground, is kept vertically on the ground, is kept vertically on the ground. The cone is kept vertically on the ground, there is axis perpendicular to HP, it is resting with its base, right? Kept vertically on the ground, full stop. It is cut by a plane which is, cutting plane which is perpendicular to, what is this cutting plane orientation? Perpendicular to VP, perpendicular to VP. It is cut by a cutting plane which is perpendicular to VP, passing through the apex and 65 degree inclined to, so this inclination I am giving, okay, 65 degree inclined to HP, 65 degree inclined to HP. So draw the sectional top view, and true shape of section, Okay, we do this homework, then we take the next problem, move on to the next category. So we missed one category. If a cutting plane is perpendicular to both HP and VP, so I have a cutting plane, we introduce cut it with a cutting plane like this. So what is its orientation? To which plane it is perpendicular? Perpendicular to both. Okay, HP as well as VP. So in where I have to represent the cutting plane? It is perpendicular to HP. I have to represent it in the top view as well as it is perpendicular to VP. Both front view and top view I will be showing my cutting plane as a line. Okay. Then where I will have my true shape? Axillary plane, that is on the side view. Right. So this category will be make a note. If a cutting plane perpendicular to both HP and VP. I have a problem in this. The hexagonal pyramid, make note a hexagonal pyramid of base side 30 mm and altitude means height, right? Altitude 70 mm is kept vertically on the ground with the base edge 20 degree inclined to VP. Right, 20 degree inclined to VP. This is the orientation of the pyramid. Right, so it is kept like this You see, in this orientation, when it is parallel, one of the base edge is parallel. So that edge is 20 degree inclined. One edge is 20 degree inclined. I have to draw the projection for this, right? Then it is cut by a plane. It is cut by a cutting plane which is perpendicular to. It is cut by a plane, cutting plane, perpendicular to both HP and VP. And cutting this solid cut by a plane both perpendicular to HP and we can have it 15 mm away from the axis. 15 mm away from axis. Right. Full stop. Draw the front view, top view, top view, and sectional side view. Sectional side view. So which in these which view will hold my true shape of section?
Axillary.
That is sectional side view. Okay. Axillary plane will hold my side view. Right. So the sectional side view will have my true shape. Since the cutting plane parallel to this, so wherever it is parallel, on that plane I will obtain the true shape. Right. On that plane I will obtain the true shape. Right. Since it is parallel to axillary plane, the side view will hold me the true shape. If it is like this, parallel to HP, which view will hold the true shape? Parallel to VP it is. So which view will hold? Front view will hold the true shape. If it parallel to HP, top view will hold the true shape. There is no separate true shape. The view itself will hold the true shape. If it is inclined, okay, if a cutting plane is inclined, there will be a separate axillary plane. You have to project it there. You have to draw a true shape. Okay, so far we have seen that. So here, cutting plane is perpendicular to both HP and VP. So the sectional side view itself will hold the true shape of section. Right. So you are asked to draw front view, top view, and sectional side view. It can be right side view or left side view. It is not mentioned. Right. Sectional side view. Any one view you can draw it. So how I can proceed this? First of all, to draw the projection of the solid. From where I have to start this? Where I have to start draw the projection. Okay, since it is kept like this, right? Since it is kept like this, okay. So where I have to draw the base? HP, that is top view. So see here in this orientation, one edge, base edge is parallel. So what is given here? It is 20 degree incline. So I can make 20 degree edge incline. So that then I can draw it. You see here. Drawing your face parallel. So now edge is 20 degree inclined, so that edge I will make it to 20 degree. So this how I have to draw an edge. So this edge will be 20 degree inclined. So this is how you have to draw your hexagon. So you draw the hexagon, proceed for the front view, then proceed for the left side view. Left side view proceed. Okay, do it. Draw the projection quickly. Draw the base, one of the side is 20 degree inclined. So you know you will be drawing the circle method. So you will be drawing the circle for construction circle for radius of equal to side. Okay, 30 radius you have drawn a construction circle. So since one of the side is 20 degree inclined, I can divide this circle to get A and D corners such a way that 20 degree inclined to the reference line. So I can divide this circle into 20 degree incline. So that I will get the intersection of that line with the circle, construction circle at A and D. Right. So using that two corners I can get E, F and BC corners of the base. So this is how I can finish off my hexagonal base in the top view. Then you mark the apex. So the slant edges in the top view, then you project these base points in the front view. So first of all, you project the apex and show the axis line have to measure the height 70 mm. Right? Then you mark the apex. So then you project all the base points. So these base points, from these base points, you join, try to show the slant edges. So what are the visible slant edges here? I can see A, B, C, D. So I cannot see E and F corners, that is EO and FO are hidden in my front view. Then move on to the side view. To get the side view, so this is the side I am drawing as per first angle projection, that is going to be my left side view. Right? So left side view I am looking. You see here. So to connect this front, so the front view and side view will be inline horizontally, linked with that. Horizontally they are linked. So similarly top view and the side view will be linked with that. This top view points, locations and the front view locations are linked with a 45-degree line. Okay, so I have drawn a 45-degree line. All the base points and including the apex locations I have projected to the 45-degree line. Then I have projected to the side view, left side view. So I have marked the apex. Then the corresponding base corners we have to mark it. It will fall on different location. Right? So once you have marked this, then you draw the side view. Okay, left side view. You see here, which one is visible? If you look at this side, this is going to be my left side. Okay. By looking from this left side, I can see F, A, B, C. I cannot see D and E. So D and E is hidden for me. So D and E, the left side it is hidden for me. The other slant edges will be visible for me. So I can join the other slant edges as a visible line. Then AO is visible, and similarly BO is visible. Then EO is hidden for me. So EO is hidden. I have connected a hidden slant edge. Similarly BO is a hidden slant edge. So this is how I have to show my all front view, top view and side views. Okay, left side view. So once this is over, try to show your cutting plane. Cutting plane is perpendicular to both HP and VP. So my front view and top view will hold the cutting plane, where I have to show the cutting plane since it is perpendicular to both. So I have to represent my cutting plane in HP as well as in VP. So and it is 15 mm away from the axis. Here, the three views, one is the front view, top view and side view. So what side view you have drawn? Left side view. So while represent your cutting plane, see here represent your cutting plane, since the cutting plane is perpendicular to both HP and VP. I have to represent the cutting plane in HP, show the cutting plane in HP as well as in VP, right? So and the same cutting plane is 15 mm away from the axis. So axis we have 15 mm away, either to the right side or left side, 15 mm away. That depends upon the side view which you are going. Right? Since you are going to a right side view, left side view, so the cutting plane you have to show it to the left side to your axis. Right? The cutting plane you represent it to the left side to your axis. Since you are going for a left side view, if you are going for a right side view, you represent your cutting plane to the right side to your axis. Right? Then only you will get the true shape as a visible one. Otherwise, the cut surface will be a hidden one. So since I am drawing a left side view, so I am representing cutting plane in both front view and top view to the left side of the axis, that is 15 mm away from the axis to the left side. So I have represented it. See here, when I have marked the cutting points. So base I will have two cutting points, then it cuts two slant edges. So two more cutting points, totally four cutting points. You mark the cutting points in the top view in an order from bottom. So this is a visible base edge, then it cuts the slant base edge, slant edge, then it cuts the slant edge, AO, then it goes for another base edge, hidden base edge, that is AM. The same cutting points should be marked in your front view. Starting from 1, it is a base, visible base edge. Then 2 is a visible slant edge. 3 is another visible slant edge, AO. Then come back on the same manner to mark the hidden base edge. 4. Right. So totally I have marked 4 cutting points. These cutting points So these cutting points 2 and 3, it falls on the slant edge. So these whatever details you have in the front view, it can be transferred to the side view horizontally by drawing projectors, right? So cutting point 2 is, see here, cutting point 2 is on which slant edge? BO, right? Cutting point 2 is on BO. You project it to the BO slant edge to the side view. I have projected it. I have BO here. So this is my cutting point 2, right? Then cutting point 3 is AO on slant edge AO. I have projected it to the side view and slant edge AO3. So coming to the base point, base cutting points 1 and 4. So it is on the same reference line. I cannot project it horizontally. So where exactly it will fall, I don't know. So what I can do it, I can get it from my top view. So top view details linked to the side view with a 45-degree line, you know. So top view, these 1 and 4 cutting points in the top view, I can see these are all base cutting points. This one cutting point in the top view, I have projected it to the 45-degree line. Then I have projected to the base in my side view. So exactly I am getting it here, 1. Then cutting point 4 in the base, I have projected to the 45-degree line. Then I have projected to the base. Exactly I am getting it 4 here. So this is my cutting point 1, 2, 3 and 4. This can be connected as a straight line of the straight line. For prisms and pyramid, it will be cutting points will be connected with a straight line. For cylinders and cone, cutting points will be connected as a curve. Right. So 1 and 4. Connected like this, 2 and 3, then 1 and 2. So this is going to be my true shape, right? This true shape, you can hatch it. This is my true shape of section, which forms in the sectional side view itself. There is no apparent section, both apparent true shape falls on the side view itself, right? So the remaining portion of the side view, listen, if the problem is given, just draw the true shape of the section in this problem, which is enough for me. Just the section alone is enough for me. I don't need to draw the side view, right? Just I can eliminate the side view. Just I can project these cutting points to the 45-degree line. Horizontally I can project it. I can just show the true shape alone, right? Now it is asked, draw the sectional side view. So the sectional side view holds the true shape. So side view, remaining side view, after removing this portion, the remaining portion also you should darken it. The remaining solid is this. So see here, listen. Listen all of you. While removing this portion, listen. By removing this portion, I have a hidden line here. So up to this I have shown. Right. Remaining portion also it will be hidden or what? This one. This one. This is my ego. The remaining portion also you have to show it as a hidden one. Right. Similarly, this ego is hidden. By looking from the side view, ego is hidden. So D2O, up to this is hidden. Still it is hidden. The hidden portion has to be shown deeply. Right. So this edge will stop up to this. Clear? This is my sectional side view. So what is asked? You are asked to draw the front view, top view and sectional side view, which is the retained portion of my front view. So that alone you have to darken it again. Finally you have to darken it, the retained portion of the front view. Dia 60 mm. So the final category is in sphere. So I cut a sphere, how will be the sectional views, right? How to draw the sectional views. Sphere of dia 60 mm is kept on the ground. It's kept on the ground. Full stop. A sphere is kept, a ball, take a ball, it's kept on the ground. So what will be my front view, what will be my top view? Both are circle of diameter 60. So this is my front view and top view, right? Then it is cut by a plane perpendicular to VP, and it is 60-degree inclined to HP, 60-degree inclined to HP, perpendicular to VP comma 60 degree inclined to HP and 15 mm away from the center of the sphere. Right. So stop. Draw the sectional top view and true shape of section. Right. So see here, draw the front view and top view of the sphere. Both are circle. So front view will be touching the reference line since it is kept on the ground. Right. So the front view and the top view both are circle. And I have represented the cutting plane here. The cutting plane is perpendicular to VP. So I have to show my cutting plane on VP. That is on front view. So front view I have to show it. And it is 15 mm away and 60 degree inclined to HP. So from the center of the sphere, I can draw a 15 mm radius circle. Right, construction circle. To that 15 mm radius construction circle, I can tilt my drafter to 60 degree, that is the inclination of the cutting plane, then remove your drafter tangent to that, such that a smaller portion is removed. Right. So you should not show your cutting plane here. So this portion, the larger portion will be removed. So you move your cutting plane tangent to that inner construction circle, that is 15 mm away from the center. And you are going to remove a smaller portion of the sphere. Right. So this is how you have to represent your cutting plane. Then, as for sphere concern design, so we cannot proceed similar to your previous problems. We will be marking the cutting points and we will be going for the sectional view. From the sectional view, we will be going for a true shape of section. So as for sphere, the true shape of section is defined. Okay, what will be the true shape of section in whatever orientation if I cut a sphere? The true shape of a cut sphere will be a circle, definitely a circle. So the diameter of the true shape of the circle will be the distance between the end cutting points of the cutting plane. Right. So the distance between the end cutting points here is the cutting plane cuts here and it cuts here the sphere. So this is the diameter of my true shape of circle. So just I can go for my true shape. Directly, straight away I can go for my true shape. Right. So true shape I have drawn a true reference line parallel to the cutting plane. Then I have drawn the true shape of the circle. The diameter equal to the end cutting points of the cutting plane sphere. Right. So this is how I have drawn the true shape. So this is going to be my true shape of circle. That's clear. Right. So I know dividing this true shape in a diametrical manner parallel to my cutting plane. So parallel to my cutting plane, I have divided the true shape. Okay, I have shown a diameter. Right. As a construction line. See here, diametrical line parallel to my cutting plane. So on the diametrical line, I am going to mark the cutting points. Otherwise, what you can do it? So I can mark the cutting points on the cutting plane wherever it passes through the sphere. So what I am going to do, some finite locations, okay, finite locations I can mark it for my cutting point on the cutting plane. So any arbitrary locations or finite distance I mark it. Right. So I will have visible cutting points and hidden cutting points in this. So what I can do is in an order I can give these cutting points. Right. Order I can otherwise starting from 1 to so I have 14 cutting points. So these are arbitrary locations I have marked in my cutting plane. Is it clear? Do you have any clarification? Right. Now the true shape normally we will be projecting from these cutting point location. So we know the true shape already we have drawn. So these cutting points I can mark it on my true shape. Listen, these cutting points, okay, in my true shape I can mark it by projecting where I can mark these cutting points. Okay, visible cutting points and the hidden cutting points. Okay, all the 14 cutting points. Okay, in an order you can give it. Right, this is going to be my cutting point. One location, other 8. Before is cutting point, say this is my cutting point 2 in an order. Is it clear? Have any clarification in this? Cutting points you can mark it any arbitrary location. Then I can project it to my. I can draw a projector from that cutting point to a new reference line, which will intersect the true shape of the circle. So that corresponding cutting points I can mark it on the true shape. Cutting plane within this extreme cutting points. Okay, you can mark any arbitrary location to show your cutting points. Right? Is it clear? So any arbitrary location you can mark. Then you number the cutting points, name it. Okay, visible and hidden cutting points in an order you name it. So using 1 and 8 distance and diameter already you have drawn the true shape. So for that true shape, parallel to the reference line, new reference line, perpendicular to the new reference line, I have extended the projector from the cutting points I have marked. Right? Then in the true shape, that projector will intersect. So that location in an order I can give the cutting point locations. Right? So this is how true shape is over. Right? Now you have to go for your sectional top view. So how I can proceed for sectional top view? So these cutting points can be projected downwards to the top view. So extreme cutting point is 1. So it can. Right? Listen. So this is how I have projected the cutting points to the top view. See here, I can draw a diametrical line in my top view also. So whatever the extreme cutting points, 1 and 8, it will fall on the diametrical line exactly in the middle. So that I have projected up to the diametrical line. So this is going to be my cutting point 1, and this extreme wherever it cuts the diametrical line, that is going to be my 8. So what about these intermediate 2, 14, 3, 13? Okay, intermediate cutting points, how I can transfer that? How I can transfer that? So this is your diametrical line 1 and 8. This is my diametrical line 1 and 8 in my sectional top view. Right? This is not up. So this is my 1 and 8. Similarly here this is my 1 and 8. How I can transfer from the diametrical line of the true shape, that is 2 and 14. How I can transfer here? So from the diametrical line, what is the distance for 2? That you measure it. This distance I am measuring it from the diametrical. Similarly on the 2 and 14 projector line, what you have drawn to the top view, from the diametrical line, transfer that. Similarly from the bottom and the top, transfer that. So this is true shape. Right? I have transferred. Then you can connect these cutting points with a smooth curve. Okay, first of all in 2-inch pencil you connect it. Then you get a smooth curve. Then you darken it. Then you match the apparent shape of section in your top view. Right? Then the retained portion, finally, the retained sphere and the retained sectional top view, you darken it. Right? Listen, I have to connect it with this. Tangently. Tangently you have to connect it. See here, listen. The true shape, the projector will likely erase it. The true shape projector you erase it. Then you hatch the true shape. Right? And you see the remaining retained portion of the sectional top view. So this portion of the sphere is removed. So I can see from 1 to 8. From 1 and 1 to, starting from 1 to 8, I have to show the sphere. Okay, the retained sphere. From 1, including the sectional apparent section, tangent to that, to the top view, you have to connect it. So that is going to be your retained portion. So this is the actual space top view. So from the cutting point 1, so tangent to that apparent shape, you have to connect it to the original top view. So this is going to be your retained sectional top view of the sphere. Right? So the final front view retained portion you darken it. Then you hatch the true shape of section, erasing the projectile lines. Okay, clear? We will move on to the next problem. It's a cube of side 50 mm is resting on the ground with one of its face such that its vertical faces are equally inclined to VP. Vertical faces are equally inclined to VP. Full stop. It is cut by a plane which is perpendicular to VP in such a way that the true shape of time is a regular hexagon. True shape of time. So the cutting plane is perpendicular to VP, and the true shape of time is a regular hexagon. The true shape of time is a regular hexagon. Full stop. Draw the front view, sectional top view, and the true shape of section. Full stop. Also find the inclination of the cutting plane with respect to the HP. So find inclination, cutting plane inclination to HP. So this you have to find out and you have to write inclination. So again, in this problem you can see the cube is kept with one of its face on the ground and the vertical faces are equally inclined to VP. So equally inclined to VP, since the cube is kept vertically, I can see the other faces, the vertical faces are equally inclined to VP. So where you have to draw the square of the cube, that is the face of the cube will be seen on the ground, that is the base of the cube. If I consider two bases in the cube has, so then the base of the cube will be drawn on HP. So the reference line will be like this, right? So the square face of the cube will be shown like this in your view. So this is where VP, this is where HP. Since the cube is kept like this on HP on the ground, so the face will be seen like this. The vertical faces are equally inclined. This is 45 degree inclined, same way the other faces. Similarly, this is also 45 degree inclined to VP. Okay, 45 degree inclined. So all the vertical faces are equally inclined to VP. So this is the way you have to draw the face of a cube in the top view. Then if I project this to the front view, so the front view of the cube will be seen. The front view of the cube will be like this, right? So give the notations for the bases. So if you consider two bases, one more phases, Q, R, S. Remember, this is A, B, C, and D. This is P, Q, R, and S. So DS, the vertical edge on the cube, it is hidden. So it is shown in different view. Now, so as per the problem, the true shape is given, and the cutting plane is given, it is perpendicular to VP. So where I have to show the cutting plane? Since the cutting plane is perpendicular to VP, I have to show the cutting plane on VP. That you know already. So the cutting plane should be represented in VP. Right. And one more thing, the inclination of the cutting plane is not given, it is asked. Right. So the inclination of the cutting plane, so you have to find it out. Apart from that, the given thing is the true shape of the section. True shape of section is a regular hexagon. So for a regular, the hexagon, the true shape to be a hexagon, it should contain 6 cutting points. So the cutting plane, whatever orientation it cuts the front view, the solid cube, so it should give me 6 cutting points. So we will see in which orientation if I cut a cube, so I will get 6 cutting points. So suppose I cut a cut the front view, use a plane like this. So how many cutting points I will get? You can see here. Here I have only one vertical edge, that is AP. So I will have one cutting point. Here I have two vertical edges. So I will have two cutting points. Here one, here I will have two cutting points, so totally three. Here it is a base. It cuts the base, passes through the base. Totally on a base, if a plane cuts, I will get two more cutting points. So totally I will have here also two cutting points. I will have totally I will have only 5 cutting points. So our true shape should hold 6 cutting points since it is a regular hexagon. So in which orientation I can cut this cube? So if you see, so this is the orientation, I should get 6 cutting points. It should cut the top base, I will get 2 cutting points. Then it should cut the bottom base, I will have 2 more cutting points, 4. Then it should cut the vertical edges which is in the middle, in the front view. That is, I have 2 vertical edges coincided in the middle. So if it passes through that vertical edge, I will get 2 more cutting points. So totally I should get 6 cutting points. So my cutting plane should pass through the 2 bases and the middle 2 vertical edges. Right. So if it passes through cuts like this, I will get 6 cutting points. So I will get 6 cutting points, it is confirmed. But the shape of the true shape, it's a regular hexagon. So regular hexagon in the sense, the true shape to be a regular hexagon. So what you have to consider, the cutting plane should pass through the center of all the cutting edges. So center of all the edges of the cube, it should pass through the center of the sides of the cube. So I can say sides of the, so suppose AB is a side, AD is another side. So center of that you have to mark it. So it should pass, the cutting plane has to pass through this center, right? This center of these faces, AB and AD, it should pass through. Similarly, it should pass through the vertical edges, that is the edge of the cube. So it should pass through BQ middle, and it should pass through DS middle, the same one. And similarly, it should pass through SR and QR sides middle. So if it passes, the cutting plane pass through the middle of the sides of the cube, then only I will have a regular hexagon. Otherwise, 6-point hexagon I will have, it will be an irregular shape of hexagon. So here I should have a regular hexagon. So regular hexagon in the sense it should pass through the middle of the sides of the cube. Right, so the cutting plane. And the cutting plane, as I told earlier, it should cut 6 edges of the cube. So if you mark the middles of this side and middle of this vertical edge and the middle of this base side in your front view, then if I connect these middles with the cutting plane, it will give me a regular hexagon as a true shape. So that is the thing you should remember here in this. So neatly you draw the front view, top view and represent the cutting plane exactly in the middle and try to get the true shape as a regular hexagon. You can see here. So this is the front top view I have drawn. Right. Then front view. And as you know, since it should give me 6 cutting points, so and the cutting plane is perpendicular to VP, I have to represent the cutting plane here. And the cutting plane, it should pass through the middle of this side and middle of this vertical edge, and it should pass through the middle of this. Then only I will get a regular hexagon as a true shape. Then I have represented the cutting plane passing through these middles. So I can represent the cutting points in an order. This is my cutting point 1, cutting the visible edge AB, and it go along the cutting plane, it cuts the visible vertical edge 2, that is BQ. That's the cutting point 2. Then you go along the cutting plane, it cuts the visible face edge, that is QR. Then you come back on the same manner along the cutting plane, looking for the hidden cutting point, that is SR, is a hidden face edge cuts, that is cutting point 4, and hidden vertical edge DS cuts cutting point 5. Then hidden base edge, that is face edge, that is 6 dash. So totally I have 6 cutting points exactly in the middle. So then you can project these cutting points to your top view to get the apparent shape of section in your top view. Then After representing the cutting plane and the apparent section, you can the retained portion alone you can darken it as usual. Similarly, as usual, retained sectional top you can darken it. Then you move for your true shape of section, that is by drawing a parallel reference line to your cutting plane and extending projectors and marking the apparent section cutting points on your true shape. So if I mark the distances, I will get a regular hexagon as a true shape. This is going to be a regular hexagon. So this is the difference of this problem. You can see the cutting plane angle is not given and the orientation, the angle is not given. The true shape is given from the true shape. So how many cutting points it will hold? It is a hexagon, 6 cutting points. So 6. You have to represent your cutting plane such that you should get 6 cutting points, and it should be a regular hexagon. Since it should be a regular hexagon, it should pass through the middle of the sides of the cube. So then only you will get a regular hexagon. Then finally, once you have drawn the true shape, then you find the angle. So it is asked in your problem. So you find the angle of this. Find the angle of this cutting plane with respect to HP, that is theta. You find it out and rotate it.